All right, so just to show you the numbers that we're going to go through. So in the simplifying expressions, we're going to do 1, 3, 4, and 7. And then for solving equations, no one said they need any help with that. And for solving inequalities, we're going to do 2, 4, 5, and 6. All right, no one said anything about the word problem, so there's none that we're going to go through with that. So you can skip along this video as you need. But let's just go through this real quick. So when we're combining or simplifying our expressions as much as possible, what we're doing in this case is like multiplying or combining like terms. Remember, like terms are variables that are identical in every way, meaning that they have to have the exact variable and then also the exact power for that variable. So one of the things I suggest when you do this is to use a highlighter. So I'm going to go through and highlight all my like terms so I know what I'm adding. So in the same color. So I see 5x. So the number out front is not what's making it like or not. That's just how many of them we have. So I see that there's an x here. So they are like terms as well. Even though I see another x here, they're not like terms because they are that has an x squared. So it doesn't have the exact same power. So in order for it to be a like term, it needs to be identical in every way. So then I look here and say, okay, well, I have a y and I have another y here, and there's no other x squared. So that's just itself. So when I combine these like terms, I add the numbers out front. So since it's a positive 5, it's 5. And it's a positive 10, so it's plus 10 x. And 5 plus 10 is 15, so I have 15x. And then when I go to add the y's, I have negative 4 and a positive 8. So negative 4 plus 8y, which is a positive 4y. And then there's nothing to combine with that x squared, so it's still just 5x squared. So since it's a positive, I am adding it. And that is our final answer for that. All right, so for number 3, remember parentheses mean multiply. And everything needs to be multiplied by this 2. So I'm distributing the 2 in. And 2 times 3x is now 6x. And 2 times negative 8 is now minus 16. And when there's nothing written here, like if I just write in x, it's understood that we have one of those. So we know that there's a number 1 in front of that, even when it's not written, it's implied. So in here, when I see minus and then the parentheses, what we're doing is we're actually multiplying by negative 1, or we're subtracting everything that follows in that parentheses. But by multiplying by negative 1, I think it's just a little bit easier. So negative 1 times 10x is negative 10x. And negative 1 times 4 is minus 4. And now that we did this, we look and see, okay, do we have like terms? Well, yeah, I have an x here and I have an x here that are the exact same variable, exact same power, so we know that they're like. And then I have a constant and another constant, so we know that they're like as well. So our x's, it's a positive 6 and a negative 10, so 6 minus 10x is minus 4x. And then we have negative 16 minus 4. Well, since they're the same sign, we know that we add them. And since they're both negative, it's going to remain negative. So it's negative 4x minus 20. All right, so for the next one, here I see I have x squared and another x squared. So they are like terms. I have an x that is the same variable, but it's not the same like term because if we were to actually know what x is equal to, we would have to square that x first before we can add anything with it. So that's why we're following PEMDAS when we're combining these like terms. And then our last one, we have a constant and a constant. So now when we go to do this, we have a positive 5 and a minus 2. So it's 5 minus 2x squared, which is then going to give me 3x squared. Then we have a negative 3 and a positive 7. So minus 3 plus 7x's, which is then plus 4x. And then we have our final of 2 plus 8, which is then 10. So it is plus 10. All right, let's go ahead and move on to here. So this now we're applying what you would have learned before in previous years, with just simplifying. In future years, you'll be actually having to solve for what the x is when you're given a perimeter. But for now, it just says simplify to find a perimeter as an expression. So we know that the perimeter is the outside edge of this triangle. And if we knew what these numbers were, let's just say this is 10, this is 8, and this is 9. And I said, well, what's the perimeter of this triangle? You solve that by adding all of your sides together, which in this case would then be 27. So even though they're not represented as like a numerical number, they're represented as an expression. So if we want to know what the perimeter is as an expression, we take all three sides and we just simply add them together because that's what it is when we're solving for the perimeter. You just add up all of your sides. So then from here, we would have our like terms of the x's, and then we have our like terms of the constants. So we add those individually. So when we have three x's, we're now doing 3. That's a positive 2, so plus 2, and a positive 6, so plus 6. So that is then going to give me 3 plus 2 is 5, plus 6 is 11, so it's 11x. And then we have 4 minus 3 minus 8, which is then going to give me negative 7. So it's 11x minus 7. All right, so for your assessment, some of your inequalities will be given a line for you, and some of them you will have to then fill in. So the first couple might just be given to you, and then you'll have to start filling them in from there. But when we do this, remember, I highly suggest that when you're solving an inequality, you always put your x on the left-hand side. And since I see the x is here on the right-hand side, I'm just going to rewrite everything exactly as it is. So 3 plus 9x. The inequality is opening towards my x, so it's going to be opening towards my x, and then 21. So we just write it exactly like it is, but just switch to sides. So since we're reversing everything and moving everything to the opposite side, we're not doing any inverse operations or anything like that. We're just rewriting it so that when we read this, it's naturally going to be on our left-hand side. You don't have to do this. It just, some people will make mistakes when they're graphing if they don't rewrite it on their left. All right, and then once we do this, same thing as every other time that we're solving equations, we look to simplify first. There's nothing to simplify. So then we're going to do our PEMDAS in reverse. And remember, for right now, we don't have to worry about parentheses or exponents. Well, 9x, that's representing 9 times x, so it's multiply. This does not mean addition, all right, because that's the variable is adding to it. So that's not what we're looking for here. It's what is being done to the variable. And since this is a positive 3, that 3 actually represents addition. So I can cross out the subtraction and division. We know the opposite of addition is subtraction. The opposite of multiplying is division, so that's what I'm going to do. So I need to get rid of addition first. Well, it's a positive 3, so I need to subtract the 3 from both sides. So now I get 9x is greater than or equal to 18. We can cross that out. Opposite of multiplying is dividing. So we're going to divide by 9. So x is greater than or equal to 2. So if you were to solve it this way, you would have still gotten it like this, where 2 is less than or equal to x. And this is what I mean. When you read that, you might graph your graph as less than because you're reading it 2 is less than or equal to x. But remember, we're always comparing the variable to the number. The variable is representing all the unknowns, so that is our solution. So when we go to graph this, it's going to be a closed circle at 2, or a solid because it's equal to. And now from here, this does break your graph up into 2 different regions, the region to the right and a region to the left. Each region, all of the numbers will either be a solution or all the numbers will not be a solution. So if you're stuck on how to know which way your arrow goes, pick a number from each region. I'm going to pick 1 and test it. Does it actually hold true? Is 1 greater than or equal to 2? No, it's not. So since this was not a solution, that means every other number in this region will also not be a solution. And then if I pick this one, 3, well, is 3 greater than or equal to 2? Yes. So since this one worked, all of them will work as well, which then means my graph needs to go in that way. And if we rewrote it like this, it does go in the way that we're reading. X is greater than or equal to 2 because we're positioning it for us to go by how it's read. Whereas this one, it's not, because when we read it, we're comparing it with the number. So that's where a lot of mistakes happen with this. So the way that I would highly suggest is where you actually check by plugging it in or rewrite it on the left-hand side. All right, so this is what I mean. For number 4 now, I give you the number line, and you have to fill in your own numbers. So we have negative 2x minus 3 is less than negative 5. So it's our PEMDAS in reverse. We know we're not going to do these for right now. The negative 2x, that is multiplying, minus 3, that is subtraction. So there's no addition or division right now. The opposite of subtraction is addition. The opposite of multiplying is division. So I need to get rid of subtraction first. So I'll add the 3 to both sides. So negative 2x is less than negative 2. And now I'm multiplied by negative 2, so I need to divide by negative 2. Now remember, on a number line, 5 is greater than 1, but on the opposite side of the number line, negative 1 is greater than negative 5. And we talked about the opposite of numbers. The opposite of 3 is negative 3 because it's a number, it's the same distance on the other side of the number line. But we also said we can represent the opposite as that negative sign. So when we are dividing both sides by a negative, what we're doing is we're jumping to the opposite side of the number line. we're going to the opposite side. And since we know that the traits of what was bigger is now smaller on the opposite side, we need to flip that inequality. So this becomes x is greater than 1 because -2 divided by -2 is 1. And because we're dividing both sides by negative, we're going to the other side of the number line, and our traits or characteristics of what numbers are larger flip. So we need to flip that inequality. Once you isolate and get your answer, now to graph it, just put that number directly in the middle. And the easiest thing is just add 1 to the next two and subtract 1. All right. But whatever you do need to be consistent. So if I did like 1 and then I did 4, I would have to do 7 next because I added 3. Then I would have to do -2 and -5. There's no like right or wrong of how you're going to write it. It's just once you establish what you're doing, you have to be consistent. So it's going to be a not closed circle. And this is now because it's not equal to, it's just greater than. And now my region gets broken up into 2. So I test, is 2 greater than 1? Yes, it is. So that means that every other number in that region will also be the answer. So I can go ahead and draw my graph going in that direction. All right, so for this one, same thing. We have our PEMDAS in reverse. We see that we have the fraction bar we know means division. It's -11, so it's subtraction. So I can cross all these other ones out. Well, the opposite of subtraction I know is addition. The opposite of division I know is multiply. So I need to get rid of my subtraction first. So since we're minusing 11, I'm going to add 11. So now I get negative x over 5 is greater than or equal to -3. So I can now go to my division. Well, what number am I dividing by? Well, we're dividing by 5, but since this is negative, we're going to treat it that we're being divided by -5. So I'm going to multiply both sides by -5 because I know -5 divided by -5 is equal to 1. And that's what we're trying to do. We're trying to isolate to get to one of our variables so we know exactly what one of them represents. What I do to one side, I have to do to the other. So now I have x. And remember, same thing, when we divide each side by a negative number, we're going to the opposite side. But if we multiply each side by the same negative number, we're jumping to the opposite side as well. So since the traits and characteristics flip, our inequality has to flip. And -3 times -5 is +15. So I'm going to go ahead, I write 15. So now it'll be 16 and 17, and then 14 and 13. This is going to be a solid circle because it's equal to. And then it breaks my region up into 2 different parts. So I can test it. Is 16 less than or equal to 15? No. So I know that doesn't work. So none of the other answers in that region work. And then I test 14. Is 14 less than or equal to 15? Yes. So since that worked, all of the other numbers in that region will work. So my graph needs to go in that direction. All right. Now this is our last one. So before we do anything with our PEMDAS, it's just like an equation. We have to simplify as much as we possibly can. So simplifying is first, is there any multiplying? And I know that's what the parentheses mean. That's what we're doing with the simplifying our expressions earlier. So we do 5 times 6, which is in 30, and 5 times 3r, which is then 15r. And then after we multiply, we say, okay, are there any other simplifying? So are there like terms? Yes. We have 2 constants here, so we can combine those. So now I have 15r. Well, 7 plus 30 is 37, is greater than or equal to 127. Once we do this, now we can go ahead and do our PEMDAS in reverse. And we know that we are now multiplying with the 15r, and we are adding with the 37. So I'll cross everything else out. Well, the opposite of multiplying is dividing. The opposite of addition, subtraction. So I'll subtract 37 from both sides. So 15r is greater than or equal to 90. And then I will get rid of the multiplying through division. I'm going to divide by 15. R is then greater than or equal to 6. So then from here, we draw our number line, 6, 7, and 8, and then 5 and 4 to be consistent. It will be a solid circle at 6. It breaks our graph into 2 different regions. So I'm going to pick a number to test. So I'm going to pick 7 first. Is 7 greater than or equal to 6? Yes. So that means every other number in that region, which is then to the right, will also be a solution. All right, that is it for this video.